Hi everyone. In my PhD project, I'm investigating the role of artificial intelligence in decision making for extubation of mechanically ventilated patients. I'm Péter Bakos, an anesthesiologist and intensive care physician, currently working in Veszprém at the Department of Anesthesiology and Intensive Care. My vision is healthcare professionals at the bedside relying on data instead of customs and traditions, while my mission is to provide evidence on data-driven decision-making in critical care. In order to achieve my vision and mission, I set specific goals. First, I'm investigating the accuracy of already existing machine learning models in predicting extubation success. And based on the results and findings of the first study, in the second step, we are planning to develop and validate a machine learning model to predict extubation success in mechanically ventilated patients. So starting with the first project and its background, the most important problem related to the topic is that almost half of our ICU patients are mechanically ventilated. There are existing national and local protocols for extubation, but despite these protocols, reintubation rate remains quite high, between 10 and 20%. Also, the extubation practice varies widely among ICU physicians, leading to inconsistencies. So what do we know so far? We know that even failed or delayed extubation may cause complications and affect outcomes, such as ventilator-free days, length of stay in ICU, or increased mortality. It has been also already shown in previous publications that machine learning can predict outcomes, such as mortality or renal failure. So what is really missing on this field is consistent guidelines related to the topic and evidence certifying the predictive accuracy of machine learning on extubation success. So what we can do for that is investigating the performance of machine learning predictive models. Our clinical question is whether machine learning models are superior to standard medical therapy in predicting extubation success. To answer this question, we would use the PIRD framework, where population is mechanically ventilated patients undergoing extubation. Index test 1 is machine learning models. Index test 2 is standard medical therapy. Reference is extubation success, and D is prediction accuracy. So our hypothesis in this study is whether machine learning model is superior to standard medical therapy in predicting extubation success. The clinical and research implication of our study would be the use of machine learning models as part of standard of care. Having these kind of tools in clinical practice could first improve our patients' outcome, second, decrease the burden of healthcare professionals, and third, enhance cost effectiveness. Here you can see a set of key articles. Actually, these articles are based on relatively small population dealing with a few hundreds of patients. They apply different machine learning models and different predictors. And as you can see, they have very high area under the curve in predicting extubation success. On the other hand, on these other key articles, you can see that the population is much higher with more than 1,000 patients. They also apply different models and predictors, and the area under the curve remains quite high. So we conducted a systematic search in 3 different databases. Our search key consists of 2 domains. Domain 1 refers to the population of the study, and domain 2 to the different machine learning models and algorithms. As you can see, we had more than 13,000 results, and after duplicate removal, we had more than 9,000 results, and we performed title and abstract selection and full text selection, and we had 25 eligible articles, while citation chasing process resulted in 2 additional results. So after performing title and abstract selection and full text selection, we are at the end of data extraction, hopefully moving forward to statistical analysis in the few days. So in the second step, we are planning to develop and validate a machine learning model to predict extubation success in mechanically ventilated patients. Coming back to the background of the first project, we know that despite the high number of mechanically ventilated patients in the ICU, the practice on extubation is still inconsistent. Also, we know that we need consistent guidelines and accurate tools supporting decision-making. For that reason, what we can do is developing a clinically relevant and applicable machine learning model. We performed a preliminary search in the literature in order to look for accessible ICU datasets. In the systematic review, we identified 4 different well-structured open source datasets, 2 from the United States, 1 from Netherlands, and 1 from Switzerland. We are planning to use these datasets in our model. So building a machine learning model consists of several steps. First, we need to start with idea conceptualization. That means we need to define the predictors and the output of our model, which is extubation success in our case. In the second step, we need to collect the data. Actually, this stage could take even years or decades. For that reason, as I showed you on my previous slide, we are planning to use already accessible, well-structured datasets. The third step is tool identification, where we need to define the programming language and the machine learning type we are planning to use. At this stage, let's move to the figure on the right in order to understand the supervised learning in machine learning. So supervised learning is a type of algorithm that applies predefined predictors and outputs. With the help of labeled large datasets, we can train our model in order to make it able to do predictions and decisions based on new unseen data. And then we can move forward to data cleaning, where we need to define outliers and find missing values and also inconsistencies. And then we can build our model. We have to divide our data set to training and validation set. And once our model is trained, we can validate its accuracy on the validation set. So what we have so far is a programming code. So we need implication and implementation of real-world environment of the model. So that is the stage of deployment. And of course, once our model is done, we need to share it with users, with physicians, and rely on their feedback in order to improve our model again and again. So here in this study, our clinical question is whether machine learning is superior to standard medical therapy in predicting extubation success. We would use the same PIRD framework as for the first project. And our hypothesis is that machine learning model is superior to standard medical therapy in predicting extubation success. The clinical and research implication of this model would be the validation in a prospective study and application in clinical practice. So in summary, first we are investigating the accuracy of existing models, and based on its results and findings, in a second step we are developing and validating a new model to predict extubation success. And for the question, when to extubate a patient, the answer, my friend, is blowing in the wind. It's in the data, but we need to find it. Thank you very much for your attention.
I was just wondering, are there any other fields of medicine where such machine learning models are already employed? Or do you know if there's any of these that are used in Hungary already?
Yes, actually, the most important field of medicine is radiology, where these models were trained, and now they are adapting to other fields as well, like intensive care and anesthesiology. And also in cardiology, they use several models, but most of the models which are approved by the FDA are related to radiology.
My question is that you mentioned that you will be planning to work with already made data sets. What are these data sets exactly, and what kind of data do they contain?
So actually this is data of ICU patients in large centers, and they have been collecting these data for decades or for years, and that's why it's very useful, because it's not a registry or not a prospective study, but it's collecting all the data of ICU patients. And for that reason, many models are trained on these data, because they are kind of heterogenic, but on the other way, they are very well structured, and they collect it in a systematic way.
Oh. Is this accessible to any physician, or do you need some kind of special authorization to get this data?
Yes, you need some authorization. You need to be a physician, an intensive care physician, to have access to them, and you need to fulfill a course. And then you can have access to them. So there is a procedure to get that access to them. Thank you.
It's a really interesting topic. I'm a plastic surgeon, so I'm not an anesthesiologist, so my question might be really general. I didn't see the dates of the studies in your first study, what you were examining, but what do you think how it will affected by the COVID? Because obviously many patient population were affected by this, and the ICU units were overwhelmed with it. How it will affect this machine learning process, because there might be studies which are before this period and there might be studies which are after this period.
Yes, there are, as I told you, several publications which treated these well-structured, already existing ICU datasets. On the other hand, for example, there is also a publication on COVID-19, only COVID-19 population. There is another one for post-surgical or cardiac surgery, so different populations are studied in connection with this topic. So we will see how they affect the outcomes. So probably if you examine a certain population, different predictors are going to be important.
My question would be in terms of the methodology of this machine learning. So which has bigger impact on the outcome? The length or the time frame of the data collection? You mentioned, so it means decades of data sets of ICU patients. So this period of time, or special predictors you collected regarding the successful of the extubation?
Yes, thank you for your question. Actually, it depends on the given publication and the given population. So I think for the period, it's all the same, whether it was a 2-month period when they collected data in an ICU or 5 years, or can be all the same. But the predictors and the machine learning type they are using, that can be very important. And these models, or actually these publications, are using lots of machine learning types and lots of predictors. For example, some publications present only ventilatory data or hemodynamic parameters. On the other hand, there are large studies which were conducted on 89 variables. So that's also an outcome of our study, to see which are the best predictors to predict extubation success. And for that reason, we, in the second step, based on the results of the meta-analysis, we want to develop an own model based on the results. Which type and which predictor is the best? That's our question.